Alright, for this particular question, we have 3 times of 9 to the power of x plus 5 times of 3 to the power of x minus 2 is equal to 0. Right, now if we look into this particular question, the only way we can solve for the x value is by converting this equation into a quadratic, right? Whenever this question comes in exam, make sure that you convert this question into a quadratic and then go for it. So if I go by that, I'll rewrite it and it becomes 3 times of 9 to the power of x plus 5 times of 3 to the power of x minus the 2 is equal to 0. Now if you look over here, we need to convert into a one common base, right? And the way we can do that is it's 3 times of 3 to the power of 2 whole power of x. Can we write it like this? And then we write this as 5 times of 3 to the power of x minus a 2 is equal to 0, right? Now this will become 3 times of 3 to the power of 2x plus 5 times of 3 to the power of x minus a 2 is equal to a 0, right? Now what we can do is we can assume that a is equal to 3 to the power of x, right? Now after this assumption, my equation is going to change, right? And the way it's going to change it becomes 3a squared, right, plus 5a minus a 2 is equal to a 0. Now because that's a paper 1 question, I have multiple ways to solve it. One of them could be quadratic. The second approach that I can use is going to be middle term breaking. So I'll go with middle term because that's way more easier. So for the middle term breaking, what we actually do is we look into this and this term. So we multiply 3 with a negative 2, it becomes negative 6. Now we need to factorize this in a way that when we add the two factors, we get a negative 6, but sorry, when we add the two factors we get the 5 that's in the middle, but when we multiply them we get a negative 6. So this becomes 3a squared plus 6a minus an a minus 2 is equal to 0, right? Because 6 times of negative 1 is a negative 6, but when I add them I'll end up getting a positive 5, right? So yeah, that factors work out. Now I'll take common from the first two and the last two. So this becomes 3a times of a plus 2, and then I do minus 1 times of a plus 2 is equal to 0. So now I will take a plus 2 as common, because if you look over here in the two terms that I have, this seems to be the common, right? So I'll take a plus 2 as common and I'm left with 3a minus a 1 is equal to a 0. Right, now you must be familiar with this property, like if the product of two numbers is 0, so this means that either a is 0 or b is 0. So I'll utilize a similar approach up here. So this becomes a plus 2 is equal to 0 and this becomes 3a minus 1 is equal to 0. So we have a is equal to negative 2 from here and a is equal to a 1 over 3. Now what was our a equal to? That was equal to 3 to the power of x, like that was the assumption that we made initially. So we have 3 to the power of x is equal to negative 2 and 3 to the power of x is equal to 3 to the power of negative 1. Right, now if I look over here, if I draw the graph of this function, so this, when x is equal to 0, this value is going to be 1, right? And because it's 3 to the power of 1, so it's going to increase like that. So we'll have an asymptote at x is equal to 0, the horizontal one. So if you look into this thing, the y value is a negative 2, which is like this, right? So if you look over here, there's a hell of a difference between them, so you can't really find out that what is the value going to be at point x is equal to negative, y is equal to negative 2. So that is why you'll have no solution for this thing, right? However, if I look into this thing now, the bases are same, so I can write that as x equals to negative 1, and this is going to be my answer for this particular question.